So you'll find that chapters have a flow. You're going to start by learning about expressions, how to simplify expressions, then you'll learn about how to solve equations, then you'll solve literal equations for a specified variable, and then you'll do applications. Now, people are always scared of applications. They see word problems and they freak out. But I'm here to tell you that it's not the word problems that's the problem. It's just feeling comfortable with word problems. Because whenever I mark the test, the people who are like, oh, I hate word problems, they're the worst, they get perfect on the word problems and not perfect on everything else. And I wonder if it's because they spend more time on this because they feel like they struggle with it the most. But I'm here to tell you that word problems seem scary, but they're okay. We're going to break them down to a place where you feel comfortable with them. So, to start with, we have to start with language. How do you interpret words as an expression? So, we're going to take some key words and just learn how to write them as expressions. So, for example, words that mean addition. If I ask you to find the sum of a number and 7, the sum is the answer of an addition question. So if they say find the sum, you're adding the two together. So the sum of a number, x, and 7. Another word that can mean sum or addition would be total. The total of 3 and a number. Another thing that can mean addition is increased by. If I have a number and it's being increased by 5, the expression would be x plus 5. So sum, total, increased by. And now we have two more. Now these ones I've put stars beside them because they're action words. They're ones that make you, instead of writing it as you see it, so for this one I went the sum of a number and 7, x plus 7. The total of 3 and a number, 3 plus x. A number increased by 5, x plus 5. When you read this one, it says 8 is added to a number. It means that you're supposed to write it as x plus 8. 8 is added to a number. Same thing here, 6 more than a number. 6 more than a number. So these two starred ones signify that the action is happening to something. And so you want to write the thing after the X in this case. So just be careful with these. Now with addition, it doesn't really matter. Whether you do 2 plus 3 and 3 plus 2, it actually doesn't matter. But when we get to subtraction, these words are super important. So let's move on to the words that mean subtraction. So the answer of addition question is sum. The answer of a subtraction question is difference. The difference between a number and 3. The difference between a number and 3. A number decreased by 12. A number decreased by 12. Then we get to these 3 that have stars. So these are going to show you that it's an action happening too. So in the first one, we've got 10 subtracted from a number. 10 is subtracted from a number. 4 fewer than a number. 4 fewer than a number. And lastly, 2 less than a number would be written like this: 2 less than a number. So the ones with asterisks, just watch the order when you're writing them. And then this third one is multiplication. So the answer of a multiplication question is the product. So if we have the product of a number and 3, the product of a number and -3. Now this is the only one where, yes, this is how it should be written. The product of a number and -3, but you will never see this. Now I put a dot. I was trying to put a dot in there. My dot didn't come out really that nicely. Ooh, what's going on there? Why didn't it like that? I'll just do this. Okay, I would normally write this as maybe a bracket, right? The product of a number and 3. You can show multiplication with a dot, you can show multiplication with brackets, you can show multiplication with an X. It's sort of up to you. I find with integers, it's the nicest to use brackets. So technically this is the product of a number and -3, but they will always write it as -3x. It's same as addition where the order doesn't really matter. Product, the order definitely doesn't matter, and this just looks weird. Now, if you put this, I'll give you full marks, but just know that the back of the book will always do this, the -3x. The second one says a number multiplied by a 6. Again, it would be a number multiplied by 6, but we're going to write it as 6x. This next one is twice a number, so it would be 2x. They could also say 3 times a number, 4 times a number, 5 times a number, right? And so it would just be written like that. Or even half of a number would be half of x. And then lastly, words that mean division. The answer of a division question is the quotient. So the quotient of a number and 8. Whatever they put after the word and goes on the bottom. So if it's the quotient of a number and 8, it would be x divided by 8. If it was the quotient of 8 and a number, the x would go on the bottom. And then lastly, if we have a number divided by 13, you'd have a number divided by 13. They don't ask the division ones too much. Usually they use the word quotient, but I know they use divided by as well, but there's very little words that are going to indicate division versus, addition and subtraction and even multiplication. So now what we're going to do is put these words into action by translating verbal phrases into mathematical expressions, and it can involve more than one of these words. So the first one is twice a number decreased by 5. So let's start with twice a number. Twice a number would be 2x. Now, if twice a number is being decreased by 5, it's just 2x minus 5. For this next one, we have 15 more than 1/2 of a number. 1/2 of a number would be 1/2 x. And if it's 15 more than that, technically it should be 1/2 x plus 15. Okay, so just use these things as guides. Just know that like more than, added to, fewer than, less than, subtracted from, those are all action words that are coming after. Otherwise, you can write them as you see them. Then we're going to go straight into writing algebraic equations, which is just more of the same. So an algebraic equation equates two expressions. So all we're going to do is take something like this and equate it to something. The key thing to look for is the word is. Is will translate to an equal sign. So for example, the sum of a number and 6 is 28. So when I see sum, I'm thinking addition. The sum of a number and 6 is 28. Now, once you have an equation, you can solve it, and you would just use your linear equation solving. So to get x by itself, I'm going to minus 6 from each side, and I would get x is equal to 22. Awesome. So the sum of 22 and 6 is 28. Check. What about the next one? The product of a number and -7, so product is going to mean multiplication, of a number and -7, so -7x, or x times -7, is 12 more than twice the number. Twice the number plus 12. 12 more than twice the number, right, is the product of a number and -7. Now, if I wanted to solve this one, I'm just going to minus 2x from each side. I end up with -9x is equal to 12. Oh, this isn't a very nice one. Then I'm going to divide both sides by -9. I would get x is equal to -12 over 9. So anytime you have a negative in denominator, just write it out front or on top. We don't like to trap it in denominators. And then make sure you simplify your answer. So something that goes into both 12 and 9 is 3. So 12 is 3 times 4. 9 is 3 times 3. So I can take out that common factor of 3. And I'm left with -4/3 is my answer. And again, to check it, I could just plug it in and just make sure that it gives me the same answer. And then lastly, the quotient of a number and 6. The quotient of a number and 6 is added to twice the number. Is 7. So the quotient of a number in 6 is added to twice the number is 7. Now, to solve this one, I'm going to look at the fact that there are fractions. So I'm going to multiply every term by 6 just so that I don't have to deal with that 6. And I end up with 12x plus x is equal to 7 times 6, not 7 plus 6. Why isn't it letting me delete? Let me just do this. Okay, is equal to 42. Then 12x plus 1x is 13x is equal to 42. And then I'm going to divide both sides by 13. And I get x is equal to, now let me just grab my calculator. Does 42 divide by 13? No. Man, these were awful questions I set up. So this one, the answer would just be 42 over 13. I can't simplify it because 13 is prime. So we've set up an equation and we've solved it. All right, go and practice these in the textbook. Oh no, my cat is about to step on my keyboard.